Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching fluid machinery in BE 5th semester. Next is Francis turbine. The inward flow reaction turbine having radial discharge at outlet is known as Francis turbine after the name of J.B. Francis, an American engineer who in the beginning designed inward radial flow reaction turbine inward radial flow reaction turbine. In the modern Francis turbine, the water enters the runner or the turbine in the radial direction at outlet and leaves in the axial direction at inlet of the runner. Thus, the modern Francis turbine is mixed flow type machine. Mixed flow modern radial fluid mixed flow type turbine. This velocity, the velocity angle at inlet and outlet of Francis turbine are drawn in same way as in case of inward flow reaction turbine. As in case of Francis turbine, the discharge is radial at outlet, discharge radial at outlet. The velocity of funnel at outlet VW2 will be 0. As the work done by water on the runner per second, here work done equal to rho Q VW1 U1, because this VW2 is 0 and the work done per second per unit weight of water striking per second is 1 by G VW1 U1. This is work done per second per unit weight of water striking per second, and hydraulic efficiency is equal to VW1 U1 by GH. These are the equations and that are used in solving the different questions. So important relation of Francis turbine, the ratio of width or the wheel diameter is given by N equal to B1 by D1, B1 by D1. The value of N varies from 0.1 to 0.4. N is 0.1 to 0.4. The ratio, the flow ratio is given as flow ratio equal to VF1 root 2 GH. The value varies from 0.15 to 0.30, and the speed ratio equal to U1 by root 2 GH, and its value varies from 0.6 to 0.9. Now we will solve some numericals on basis of these equations. We will solve one numerical. A Francis turbine with an overall efficiency of 75% is required to produce 148.25 kilowatt power. It is working under a head of 7.62 meter. The peripheral velocity of 0.26 root 2 GH and the radial velocity of flow at inlet is 0.96 root 2 GH. The wheel runs at 150 rpm and hydraulic losses of turbine are 22% of the available energy. Assuming radial discharge, determine first guide blade angle, second wheel vane angle at inlet, third diameter of wheel at inlet, and fourth width of wheel at inlet. Here the data given are overall efficiency is 75% equal to 0.75. Power produced, that is shaft power, equal to 148.25 kilowatt. Head is given 7.62 meter. Peripheral velocity U1 equal to 0.26 root 2 GH. Putting the values here, 0.26 into root 2 into 9.81 into H is 7.62. So this comes 3.179 meter per second. Velocity of flow at inlet VF1 equal to 0.96 through 2 GH. Replacing the values, H is 7.62. So this value of VF1 comes 11.738 meters per second, and is given 150 rpm. Hydraulic losses is 22% of losses is given 22% of available energy discharge outlet is radial. This is important for the Francis turbine. Discharge at outlet is always radial here. So VW2 equal to 0 and VF2 equal to V2. VF2 equal to V2. Hydraulic efficiency is given as theta hydraulic equal to total head at inlet minus hydraulic losses is divided by head at inlet so H minus 0.22 H by H. So this comes 0.78. But as you know, eta hydraulic equal to VW1 U1 by GH. So putting the values here 0.78. Now VW1 we have to calculate from here equal to 0.78 into 9.81 into 7.62 is divided by U1 3.179. So the value of VW1 comes 18.34 meter per second. Here, now we have to calculate guide bed angle alpha. Guide bed angle here 10 alpha from inlet angle 10 alpha equal to VF1 by VW1 VF1 by VW1, putting the values here 11.738 by 18.34 equal to 0.64. So the value of alpha equal to 32.619 degree equal to 32 degree 37 minutes is value of alpha, and the wheel well angle at inlet theta, wheel well angle at inlet tan theta equal to VF1 by VW1 minus U1 11.738 by 18.34 minus 3.179. 3.179. So here the value of theta comes 37.74 degree or 37 degree 44.4 minutes is the value of theta. Now we have to calculate the diameter of wheel at inlet diameter d1 equal to pi d1 and by 60. So d1 by pi and equal to d1. Putting the values here, 60 into 3.179 by pi into n is given 50, 150. So here the value of d1 comes 0.4047 meter. This is the value of d1. Now width of wheel at inlet, width of wheel at inlet, V1 we have to calculate. So eta overall equal to shaft power by water power equal to 148.25 by water power. But as we know, water power equal to Ws by 1000 equal to rho G Q H by 1000. Putting the values here, eta overall equal to 148.25 is divided by 1000, the value of flow for water 9.81 G. Then Q value we have to calculate, and this is H is 7.62 meter is divided by 1000, cancelling this 1000 both, and the value of overall efficiency is 0.75 overall given. So we have to calculate Q from here. Q equal to 2.644 meter cube per second. Using the equation, as we know, Q equal to pi d1 v1 vf1 2.644 equal to pi into d1 value we have find just 0.4047 into V1 into 11.738. So here the value of V1 equal to 0.177 meter. So likewise we have to solve more and more numericals in this topic from university question papers, etc. And one thing I want to tell you that this inlet and outlet triangle are very important while solving these questions of turbine. Thank you.